Question 4 reads, which best describes the image of a concave mirror when the object is at a distance less than the focal point distance from the mirror? So what's important to know here is that we're considering the image of a concave mirror. So the image of a concave mirror is going to differ significantly from that of a convex mirror. So if you'd like us to cover a convex mirror, we can do that also in a separate video and add it to the Week 9 playlist. But a concave mirror, you should know, can create real and virtual images. And there's actually 5 different cases of mirror reflections for a concave mirror. And so these 5 sort of combinations are shown below, with the distance of the object farthest in the top left and the distance of the object closest in the bottom right. And so there's really no other way of getting around this than sort of brute memorizing, unless you really want to draw the lines as the light is emitted from the object. But there's a sort of an easy way to memorize this, in that there's a logical progression of magnification going from smallest to largest, and then also the fact that the image goes from real to virtual. And so one way that you can remember this is that for the farthest, when the distance of the object is the farthest away, it's past the radius of curvature, then the magnification is going to be less than 1. So it's going to be at its smallest point. And then so you should know that when the object is farther than the radius of curvature, then it's going to be real and inverted. And so as we move forward here, we can see how it goes from less than 1 to equal to 1 to larger than 1. And then this is sort of an exception that you have to know, that no image is produced when the object is at the focal distance, but then it ends up being larger than 1. So if you recognize the fact that as the object gets closer to the mirror, then the magnification is going to increase essentially, and so that'll just help you memorize that it's less than 1 for past the radius of curvature, equal to 1 at the radius of curvature, etc. And then so next, I want to bring across that you can see how like I said, there's no image produced when the object is at the distance of the focal point, but this can help you memorize whether the object will be real or virtual, in the sense that when it's closer than the focal distance to the mirror, then the image will be virtual and upright, and then any point beyond the focal point will be real and inverted. So these are just some helpful ways to memorize for a concave mirror. So for this question, the answer is D, and so you can see that from looking at the diagram in the bottom right.